going to tell you today about something we call nanosatellites. Has anyone ever heard of a nanosatellite? Raise your hand if you okay. Yeah, well, that's because you guys were at Hilton. That's kind of cheating, and I know Alvin has. So nanosatellites, well, a number of years ago, people that built satellites decided that they were going to make satellites that were smaller than typical ones. And the typical ones were the size of a small car. And so they decided any satellite under 100 kilograms would henceforth be called a microsatellite. That's a different sense in which than which we use in Microsystems. And then, of course, somebody at university came along with the idea that they would make still smaller satellites. So they decided anything under 10 kilograms would be called a nanosatellite, since the ones under 100 are micro. And yes, there are picosatellites too. Those are under a kilogram. And they're typically in cube form. You'll see a couple of images of some. These are, some people, although these are not cubes, some people call these 3-cube nanosatellites. They are, in fact, approximately the size of 3 conjoined 10-centimeter cubes. And in fact, our science experiment in most of these occupies about 2 cubes worth, so 20 by 10 by 10 centimeters. And the spacecraft brains, called the bus in the space industry, that has the radios, the batteries, and so on, that's about 1 10-centimeter cube. People do things with just a single 10-centimeter cube, but what they don't tend to do is live biology experiments. We found that the complexity that you need to do something interesting, like looking at gene expression in outer space, requires more than a single 10-centimeter cube in total. So these are big nanosatellites. They typically weigh about 5 kilograms, and we launched the first